Hi, I'm a Bull student tutor, and in this video I will be talking about blood typing, genotypes, and phenotypes. For blood typing, there are 3 types of alleles that code for the blood typing. So there is big I to the A, big I to the B, and little I. So big I to the A and big I to the B are codominant with each other. So codominance means that both alleles are expressed equally and they're not blended together. And then I, the little I, is recessive to these 2 codominant alleles, because even though they're codominant, they're still dominant. Okay. Different combinations of those alleles make 4 phenotypes for blood types. So they are the common ones that you know. They are type A, type B, type AB, and type O. A is usually the most common, and O is usually the least common. So these are the different allele combinations that code for the phenotypes. So for phenotype A, there is either I to the A, big I to the A, and big I to the A, or big I to the A with a little I, because remember what we said before, even though big I to the A is codominant with big I to the B, it is still dominant over the little I. So since big I to the A is dominant over the little I, that is the one that will be expressed. So either one would get you to type A. And then for type B, there is big I to the B, big I to the B, big I to the B, big I, little I. And that's how you would get type B. For type AB, this is the part where codominance comes in. So it would only have one allele combination that could get phenotype AB. Big I to the A with big I to the B. Because they're both together and they're both codominant, that means both of them will be represented, and we'll talk about that, what that means a little bit later on. And for type O, since it's recessive, it has to have 2 alleles that represent O. So it would just be little I, little I. So this is what I was talking about before. So what it means when you have A or B or little I, it refers to the carbohydrates on the surface of the red blood cells. So, alright, so for type A, the carbohydrates that are on the surface of a person with type A, their red blood cells have carbohydrate A on them. So, and then for type B, you would have carbohydrate B. For type AB, you would have both carbohydrates A and B together, but both represented, not blended. And type O is usually seen as O for 0, because there are no carbohydrates found on the surface of someone with type O for the red blood cells. For blood transfusions, this information is very important because when you're talking about blood transfusions, it has to do with the immune system. So your immune system is constantly looking at all of your cells to make sure that they're all in order and that there are no outsiders. This is also how it attacks cancer. So for type A, people with type A blood could only get blood transfusions of type A or type O because people with type A would have only the A carbohydrates on the surface of the red blood cells, so the body who's receiving the transfusion would see it as their own cells and would not try to attack it. As for O, since it has no carbohydrates, the immune system overlooks it and no problems are caused. If A were to have B on it, so if someone that had type A for a blood got a transfusion of type B, they would cause a lot of issues because the immune system would try to attack it because it sees it as a foreign cell. And so it would cause a lot of blood clotting, and it would seriously injure or sometimes even kill the person who received the blood transfusion if you didn't get there in time. So for type B, it's the same thing, except it would have to have carbohydrates B, so type B or type O. So that is not possible. For A and B, you can either have type A, type B, type AB, type O. This is what makes them universal receiver, because they can receive blood from any type of blood. For type O, since they have no carbohydrates on the surface of their red blood cells, they're the universal donor. But because they have no carbohydrates on their cells, that means they can't receive any blood from any of the other blood types. So for O, they can only receive blood that's type O. Okay, so now we're going to look at hybrid crosses for the blood types. So we're going to look at the genotypic and phenotypic ratios and chances of the offspring getting certain genotypes and phenotypes from the parents. So for the mother, let's say the mother has the blood type AB, so that would be represented as big I to the A, big I to the B, and the father has type O, so that would be represented as little I, little I. So, if you're watching this video, you most likely have some background knowledge in basic biology, so we're just doing a basic Punnett square here. So I'm going to 4 sections. So I'm going to put the mom on the top. So big I to the A. Oh, that's not an A. Big I to the B, and then little I, little I. So if you don't know what Punnett square is, you just put them together for the boxes that correspond with them. So I take that from up here, type big I to the A and little I. Big I to the B, little I. And then down here, it's just the same. So it's just a trick we can do. We can just pull it down because it's the same thing up here and same thing right here. So the genotypic ratio, you just count them. So So for the possibility of the offspring getting big I to the A, little I, to big I to the B, little I. So if you look at the chart, it's 2 and 2. And you do not cancel out any values. It's very important to the data to not cancel out values. And then for the phenotypic ratio, look at the blood type. So what these two mean and what these two allele combinations make as a blood type. So it'd be 2 type A to 2 type Bs. Alright? So this working with blood type is also very important in paternity cases. This is how you can determine if someone is the father of a child or not. So let's use an example. So if the mother is type A and the child is type B. So this is the information you're given. If you were given this information in the court, you would have the father tested for the blood type, but you have to determine what possible blood types he could be and what he can't be. So we're just going to determine what the father would have to be in order to be the father. So if the child has the B, it has to have at least one I to the B, and it can't have an A, or else they'd be type AB. So it's either going to have a big I to the B or a little I. But if you see the mother has to have big I to the A, and you can't have big I to the B, or else it would be AB as well. So in order to get from the mother to the child, it would have to be the recessive, the little I, passed down from the mother. So this is the allele passed down to the child. So the allele that corresponds with type B, so big I to the B, would have to come from the father. So this is basically just working backwards. So, you must give an IB allele. So you look at the blood types and the genotypes that have that. So these are the options: big I to the B, big I to the B, big I to the B, little I, because that would still be type B, and it would still give a big I to the B allele, and then big I to the A, big I to the B. So the blood types of the father, the possibilities would be either AB or B. So if in a case or in the court you saw that from a blood typing that the father or the presumed father was not one of these, either type AB or type B, then he would be ruled not the father. And then if he was type AB or B, he would be presumed as the father, but there would be other tests for that. This has been a Bolus Student Tutors video. If you enjoyed this video, make sure to check out the rest of our YouTube channel for more tutoring videos. Thank you.